All right, the technique I'm about to show you here for graphing a line is the model of efficiency for graphing lines. In other words, it is the best way to graph lines. If I ever have to graph a line, I use this technique. The only time I use any other technique is when to make a point, like the last problem. How long did that problem take? Forever. All right, so this right here is not going to take so long. All right, it's going to be much quicker. I've got to explain myself, so the explanation is going to take time, but the actual graphing process here takes maybe 30 seconds to get good at it. And once you're good at it, and once you get really good at it, you're probably down to 15 seconds. The first step of slope-intercept method of graphing is you want the equation to say y equals. We had to do that in the other problem anyway, right? And so this is not even a point of argument here as far as why this technique's better. We got to do the same stuff we did in the other technique. There's no saving time on either technique in this situation. So if I want this to say y equals, job one is to get y by itself, so 3y stays right where it's at. I move the 2x to the right. Every time I do this, you'll notice that even if you look back at the last problem, when I move the x over, I put it in the first position over here. I like y equals x plus number. I like that structure. I just want to get used to that structure. For me in math, anytime I get some kind of a structure of some type of equation that happens a lot, I like to put it the same way every single time. So every single time I look at my paper, everything's in the same place every single time. So I don't have to take an extra second to figure out what thing is what. I know right here's where x is, right here's where the number is, right here's where y is. Everything goes in the same place every time so that I know I've got my thoughts organized, I can find it much more quickly. Divide by 3, divide by 3, divide by 3. Those cancel. That doesn't. This reduces, right? So that's y equals. What's left is negative 2/3 x plus 2. So that's my first step. If I'm going to use the slope-intercept method of graphing, get it to say y equals everything else. And again, my recommended order is the x term first, the constant second. That's just what I recommend. All right. The two things we need to get from this graph are the slope. The slope is always located in front of the number x, sign included. Whatever's in front of x is the slope every single time. Slope in this case is negative 2 over 3. The minus sign can be on the bottom also, it doesn't matter. So the slope is either negative 2 over positive 3 or positive 2 over negative 3. Both fractions have a negative value. But that's where slope's always located. Again, getting back to that point about putting things where they belong, if I always go y equals something x plus something, the first number is always the slope. The first number I'm looking at in my equation is always the slope, but it's also the number attached to the x is the slope. The y-intercept is the constant. It's the number that has no x attached to it. It's positive 2, and it matters that it's positive. All right? So basically that's your starting point if you're going to do slope-intercept method of graphing. Get y equals everything else and identify the slope and the y-intercept. If there's no x, the slope is 0. If there's no constant, the y-intercept is 0. Yes, Maddie?
Do you always just do that on paper? Like, write it out?
I would always, if I was doing slope-intercept method of graphing, I would write down my y equals, I would identify my slope and y-intercept. I would at least put m equals and b equals, if you don't want to write slope and y-intercept out. We usually refer to slope with the letter m, and y-intercept with the letter b, and our structure is usually y equals mx plus b, right? That's what we usually look at with slope-intercept method. Going back to Algebra 1, we saw this last year. Slope is always m, b is always y-intercept. So at least m equals and b equals should be on your paper. I would always do that. Okay? Once you've gleaned this information from the equation, you're ready to start putting points down. The y-intercept is your starting point. The y-intercept, where it intercepts the y-axis, where it crosses the y-axis. You simply count. Again, if the y-intercept is 0, it's right here at the origin. Y-intercept 2 right there, negative 1 would be here, positive 5, 1, 2, 3, 4, 5 would be right there. Negative 3 would be 1, 2, 3 right there. Whatever this number is, just go to the y-axis and go to that position on the y-axis, like you're graphing on a number line. Where's 2 out on the number line on the y-axis? 2 up. Where's negative 3? 3 down. Where's 0? Right there in the middle. All right? So whatever that number is, that's how you plot that. Then you use the slope to get the next number. Slope is rise over run. Vertical over horizontal change. Okay? It'd be like me telling you to go to the store. Okay? You go 4 blocks to the north and you go 1 block west. If you only go 4 blocks north, you're at the store. If you only go 1 block west, you're at the store. No, you got to go both directions to get to the store, right? What? You'll be on the right street, but you won't be at the store, right? You won't be able to buy eggs if you only go 4 blocks north. You'll be standing there, and you can go to the antique. You can look at the antique store. You can might be right around those bushes up there by the corner, whatever. But you don't get there. So just take this slope here, positive 2 over negative 3. That's up. Because with up or down, plus is up, minus is down. With left and right, plus is right, minus is left. Alright? So, I'm going up 2 and left 3. So, if I'm at my point here, and again, this point's on the line. Alright, anytime you got your starting point here, so you're on the line already, you do the directions, go up 2 and left 3, that point is also going to be on your line.
Down.
And also, if I use this slope here, let me use a different color. If I did that slope, that's going to be down because the top number is negative. Up or down, negative is down. And the bottom number is positive, that's right. And again, for the bottom number, positive right, negative left. All right? So, if I'm at this point, again, my starting point, and I go down 2 and right 3, that's also a point on my line. Okay? Simply use the slope to identify more points. The y-intercept is a point. That puts you on the line. The slope tells you how to get to another point on the line, or another point on the line. All 3 of those points are on the line. We connect the dots with a nice straight line, like so, and there's your answer. And just real quick, I didn't pick this point, but watch what happens. If I'm here, right here, and I go same slope, this one right here, if I'm right here, I go down 2 and right 3, look, I'm still on the line. That's all slope is. It's saying you're on the line, here's how to get back to the line. Okay? Do this and you're back on the line again. So just follow the directions. So starting point, directions to another point. Once you get 2 points, you get a line. Once you get 3 points, they line up all nice straight line. And again, that whole process to solve this, to identify these numbers, to graph that, to use that to get more points, takes about 30 seconds. When you get really good at it, it takes about 15. All right? Most efficient technique of graphing lines, I would always use this method personally. And again, I know it's linear. I know it's a line 100% of the time. If x is to the first power, y is to the first power, they're not being multiplied together. There's no other powers showing. Once powers start happening, x squareds and y squareds, curves start happening. Once x's and y's are being multiplied together, curves start happening. Only x to the first and y to the first line. One more thing I want to throw at you real quick in case it happens in your homework, which it probably will because they usually do this. Suppose you get this equation. Oops. It's supposed to be a white rectangle. We're going to throw 2 equations at you. First equation, y equals 4. Second equation, x equals 2. Those are both lines. How many powers do you see? None. X to the first or y to the first. There's not both x and y. All right? But it's just x to the first power equals number, y to the first power equals number. All right? So if I go to my graph paper, all right. This is my y-axis, this is my x-axis, right? Take a look at the blue line. Y equals 4. Again, I know it's a line. Right, it's y to the first power equals number. Right? The only requirement of that line, that equation to be true, is that y equals 4. What does it say x has to be on the blue in the blue equation? The one I got circled here. What does x have to be?
Nothing.
Not nothing.
1.
Oh, it could be. Let's go with 1. 1, 1, 2, 3, 4. All right. Does that point make this equation true? That point is 1, 4. Yeah. Y equals 4. Y equals 4. That point is true, right?
Whatever.
All right, so x could be whatever. And I heard anything from over, I think Emily might have said it. All right, anyway, x can be anything. Y has to be 4. So if you're looking at a linear equation that has x and y, you're going to get slanted lines. If you have y equals number, you're going to get a straight, unslanted line. Y equals creates a horizontal line. That messes people up because the y-axis is vertical, but y equals makes a horizontal. But again, let me show you why. X could be 0, y has to be 4. X could be negative 1, y has to be 4. X could be negative 2, y has to be 4. X can be positive 2, y has to be 4. Y has to be 4, y has to be here, x is free to move along the line and be anything it wants to be, right? So that's why it creates a horizontal line. Because y has to be 4, x can be what it wants to be. You're free to move left and right, you have to go to the height of 4. Similar argument for the other one. The board's not cooperating with me for erasing today. X has to be 2, what does y have to be? Anything it wants to be. So if x is 2, y could be 0. If x is 2, y could be 1. If x is 2, y could be negative 2. If x is 2, y could be 5. That red equation, x has to be 2, y is allowed to be anything it wants to be. So if you get x equals just a number, you're going to get a vertical line. Again, messes people up. X-axis horizontal, x equals makes a vertical. It just does. All right. Beyond that, linear equations, those two special cases, every other linear equation will be slanted. And you know it's slanted if you have x and y both in it. If x and y are both there, you're going to have a slope and a y-intercept. Slope takes you down and right, or up and left, or up and right, or down and left. All right, one of those four directions. And if you have to go both up and over, you're going to create a slant. All right, so special cases, x equals number, y equals number, just graph it. I don't take more than 3 seconds to graph one of these. X equals 2, vertical line, next problem. All right, this one, 15 to 30 seconds, depending how well practiced you're at it. Be able to graph lines, they're easy. When we get to curves, they're a little bit more challenging, but not much.